Right, good morning everyone. It is Wednesday, so that means it's time for our science lesson. Oh, sorry, that's in the way. So today we're going to be doing our last science lesson on space, okay? Had a look at the last two lessons, 2 or 3 I think, okay? So we're going to be looking at the last few things we need to in space at the minute. That looks fine. Okay, time is, let's have a look, 4 minutes to, 4 minutes time. We are going to get started, okay? Just give people time to join us in the chat and everything. 4 minutes time, we'll be getting started. Good morning, Julianne. Morning, Maya. Morning, Ryan. Good morning, the Smith family. Good morning, Ollie. Let's have a look who else is in here early. Morning, Chloe from Mill Hill. Morning, Chloe. Morning, Julianne. Morning, Drew. Morning, Leah. Good morning, Millie. Morning, Milo. Morning, Amelie. Lucy. Layla. So I've got there. Tom, good morning. Abdullah. Francis. Emily. Morning to all of you guys. Nice and early as always. It's always the same people in early. Got 3 or 4 minutes and we'll be getting started. Morning, William. Jude, we're starting in 3 minutes or so if you need to get anything. Okay. May the force be with you as well, Julia. Morning, Heidi. Good morning, everybody. Good to see. Morning, Dawn. Good morning, Sophie. Oh. Good morning, Emily. Hope you're annoying, William. Good morning, Miss Allison. I saw the chat. Good morning, Mrs. Rice as well. Good to see you. I'd say bright and early, but morning, Jodie. Minute or so, just about to get started. Let me get a drink. Oh. Morning, Evie. Good to see you. Morning, Christian. This message before we get started. Oh. Fine. Okay, 10 o'clock. So, welcome down, guys. Going to get started now. It's 10 o'clock. Like I said, this is the last science lesson I'm going to be doing on space. Obviously, it's half term next week, so we won't have a lesson there next week. Just going to mention, in case I forget, I will try and mention at the end as well. Tomorrow, I'm supposed to be doing a music and sort of a music lesson in the morning and an art lesson in the afternoon. I can't do my art lesson in the afternoon because I have to go into to school and to get some to do some work in school. Okay, so I can only do my lesson on music in the morning. So there'll be one lesson tomorrow. I'll remind you at the end, but that's just so you know. Okay, so as you know, we've been doing about space. And we've been looking at lots of different things, the planets, orbits, the moon, all those phases of the moon, all those type of things. And the last thing we're going to look at today is the sun, days on Earth, days and nights, shadows, things like that. All that happen because of the sun. Remember, as any lesson, quick reminder about the chat. In the chat, please, okay, popping stuff down about the work, any answers and things that you have. Teachers are in there and they're watching for people spamming the chat, for people distracting other people by talking about other things. And if they are, they will time them out, which means you can't write anything for 300 seconds. And then they might have to hide you if you're talking over and over again. Okay, we don't want to do that. Okay, we want you to go in. A lot of times I do see people saying why we've been timed out and stuff like that. Now when I look back in the chat, they've been talking about Fortnite or something and adding people on YouTube and stuff like that all the way through. Okay, that makes it when I'm checking answers, what people are saying for answers, really, really hard. Okay, and for other people who are trying to keep up and see what they're doing, it distracts them. Okay. So if you are distracted, I trust the judgment of the teachers and the moderation there must be for some reason. We don't want to do it, okay? Again, if you need help as well, you can pop it in the chat, but we might miss it. If you definitely need some help on something, maybe after the lesson when you're doing work or something, you can get in contact by putting a comment on the video. You can go to my social, Facebook, Instagram, or Twitter, Mr. Biggins123. Type those in, you'll find me. Okay, you'll see this fella. That'll be my pages. You can ask for any help on those or send us work, which is brilliant. And also on the Padlet where you'll be able to get the worksheets and work to go with this lesson afterwards. And there's place on there where you can email and things like that. So lots of different ways to get in contact. And a last little thing before we start is the winners of last week's Science Kahoot. So the online quiz that you all do. Okay. Let's have a look. So the online quiz, okay. We had with first, second, and third. So in third place, we had Freya, who scored 16,000. Freya LT, sorry, who had 16,357 points. Well done, Freya. Round of applause. Okay. And then in second place, now on the Kahoot this week, what I've been doing is I've been leaving the timer on. So the quicker you answer the question, the more points you get. Okay. Listen to the points here. In second place, Jenna G got 17,357 points, so round of applause. But the winner, remember Jenna G got 17,357, got 17,358, one more point, so it was probably a second, if that, in it. They got the same amount of right answers. One of them just got one of them a fractionally bit quicker, and that was Stephen. Okay, no initial on there. I do know a couple of Stevens who watch the videos, so it could be either of them. But I'm sure you'll know if you got that right. So well done to those. Okay, big round of applause. And again, there is going to be an online quiz that you can have a go at after today's lesson as well. But let's get on with the learning because we need to learn before we can answer the questions, don't we? So today we're going to be looking at the sun, shadows, all those type of things that happen. And when we look up at the sun during the day, okay, it looks like if we stood there all day, or if we took a video, left it there all day and we sped it up, it looks like the sun moves across our sky, okay? However, from what we've learned, we know that that's impossible. The sun doesn't do that. The sun's not moving across our sky. Why do we know that, okay? From what we've already learned in previous lessons, or if this is your first lesson that you've joined us in, what is it that we know about our planets and our solar system that lets us know that we know that the sun doesn't go across our sky? Why do we know that the sun can't be going across our sky? It looks like it does, but we know that it mustn't be. And why do we know that? Okay. So Julianne mentioned in there, okay, saying something about and Seb and Isabel and Maya's the to mention it, okay? Lots of people saying we move. Yes, we move, but Maya's the first person that mentioned the sun doesn't move, okay? And that's the biggest point there. So the sun doesn't move, okay? We orbit around it. We looked at that, and lots of other things do, including all the other planets, orbit around the sun, okay? But the sun doesn't move. So when we look up the sky and we can see the sun moving across, we know something else must be happening, okay? Because obviously, we know the sun doesn't move. Sorry, lost my train of thought there. So, we're going to look at why it is that the sun moves. Now, it looks like the sun moves because we rotate. And we looked at that and we found out, yes, there last week, okay, we found out that we're on a little bit of a tilt. You can see with my Earth on there. So if we've got, where are we? Here's Europe here. So we're on a little bit of a tilt and we rotate around. And we know that when we rotate around, it takes 24 hours for us to go all the way around, okay? And that's why we have day and night, and that's what we looked at last week, okay? But the reason that it looks like the sun is rising and dropping, okay, is because of our rotation. So let's find us in the UK here. So we are here, okay? And let's say you're the sun. So from your point of view, I'm going to put the camera on so I'll make sure I've got this in the right position. So let's say I have got the Earth here, okay? I've got my finger on where the UK is, okay? Now, just check to see that you can see everything here. Now, you can see now that I am behind the sun. This will be night and we can't see it. So our Earth rotates, and like we said last week, it rotates around and it takes 24 hours for it to go all the way around, okay? Now, our planet rotates from west to east, okay? So we have our compass directions. North, okay, would be up towards the North Pole. South would be down towards the South Pole. East and west, okay? And those are the 4 directions. Now, our planet rotates from west to east, which means it rotates around this way, okay? That's the way that the Earth is rotating around. Now, if I am here, okay, you can see as we come round, you're the sun. As we get here, the sun would be up in the east part of the sky because of where you are. Then as you rotate around, you would get to midday, so the middle of the day, and that would be when the sun looks right up in the middle of the sky, highest that it will be, okay? And then it will continue to rotate around as the Earth goes, and that's when the Earth starts to set and starts to go down into the west, and then it is gone and we can't see it, okay? And the moon we can be able to see. And that is why when we look up, okay, we can see the Earth rise in the east and set in the west, okay? It looks like it's rising in the east and setting in the west because we are going the opposite direction, okay? Imagine if I'm here, as I'm turning, okay? I can see that. Now, I can feel that I am turning, okay? I know that you as the sun or the camera, okay? As I turn around, I know that you're on the west, the east side of where I am looking. And as you go, you are moving across where I can see. Now you're right in the middle of where I can see. And now you're on the west side. Now I know that it is myself moving, okay, and not the camera because of the speed that I'm rotating around. However, because of the size of the planet, Earth, and the speed that we are moving, we don't feel like we are moving, okay? So you know every day when you walk around, you don't feel like, whoa, we're going round. And our Earth spins around very, very fast, okay? It might take a whole day to go around because it's so big, it has to travel at a really, really high speed to go around. But because of the way our bodies are made, we cannot feel that movement, okay? We can't feel that movement of us spinning around. Otherwise, every day you'd be walking around, you'd be having to hang on because you'd be able to feel the Earth around. Because we don't think that we are moving, okay, and we can't see that we are moving because the sun's so far away and we're so close, it looks like the sun is moving, okay? And that's why it looks. Now, I mentioned this a couple of times, but the sun doesn't just go from left to right, okay? It doesn't just go across the sky like that, okay? I'm going to put some notes down in case you're wanting to write notes down there. So, rises in the east. And sets, which one means it goes down, in west, okay? And that is because the Earth rotates from west to east, so the opposite, west to east. Okay, so the sun rises in the opposite way that we are spinning. Now, what I was going to say there is the sun doesn't just go across like that, the sky doesn't just go from east to west, okay? It looks like it goes up and then it looks like it goes down. Does anyone know what time around about, okay, because it does change slightly every time of the day, but only by a couple of minutes, couple of seconds, okay? Does anyone know what time the sun is the highest in the sky, okay? Well, looks highest, because as we know now, the sun's not moving, okay? But when does the sun look highest, okay, in the sky, okay? So it's not just going across in a straight line, and it's just there going across. It goes up and it goes down, okay? Does anyone know what time it is? And I've mentioned it a couple of times when I was spinning the earth around there. Let's have a look at the chat. Does anyone know what time? Someone's got a time in there, but remember, there's two different times of the day. There's 1 all the way up to 12 in the morning and in the night. So you need to tell me, are we talking about morning, afternoon, night time? When can you tell me? Obviously, I'm assuming you're going to mean daytime, seeing as we can't see the sun at night. So lots there. Julianne, okay, well done. Mohammed, Evie, Isabel, Dawn, Jasmine, Tom, Chloe, Billy. Okay, some really good answers in there. Okay, now it does change slightly now because we don't have the same. Oh, we don't have the same. Okay, we don't have the same. Sorry, I'm just getting the wrong screens up. We don't have the same time that is very, very high in the sky every time, but the time that is the highest is noon, okay? Which is why when you ever hear cowboys talking back from the old west and stuff like that, we'll see you at high noon. They're called high noon because noon is when the sun is highest in the sky, which is 12 o'clock at dinner time. Now it can, I'm not sure which way, but it can go around about a quarter of an hour each way, okay? 60 minutes that way, 40 minutes that way, depending on what time of year it is, okay? And that's just because of the way that we're traveling around the planet. But it is 12 o'clock noon, so obviously not 12 o'clock at night because we can't see this in there, but that's why they do it there. And that's the point, that it is directly sort of above us or directly in front of us, however you want to see it, when you're thinking of the planet. Now, because of this movement being regular, okay, and around about 12 o'clock, I already mentioned there that high noon, okay, the cowboys would say, oh, we'll see high noon, and that will be the time. Now, we have clocks and we have all sorts of ways to tell the time these days, but because of the regular movement of the sun and the different times of year, people over the past have actually been able to use it, because it's that regular, to navigate, so to be able to find their places around, way around places, and also to tell the time, okay, so they can look at the sun, okay, they can see it's right in the middle, right, it's about 12 o'clock. Now, as they go on, as you can see, it's nearly setting, right, it's about that time. And lots of very smart people would write down at different times of the year what time it would set, which is why on your phone now you can get sunrise, sunset, okay, smart people are still doing it, and you know what time the sun's going to set. They would know that, they check charts, so they know what time it is by where the sun is, before everyone had access to clocks and to alarms and phones and things like that, okay? And also obviously navigation, because if you know it's 12 o'clock, if you know it's sunset, and the sun is over there, and you're going, towards where the sun is, you know that's the west because the sun sets in the west, okay? So it used to be able to be used by navigators and by people to tell the time, okay? And we're going to have a look as well a little bit later about how they would use it to tell the time, okay? Now, although when we say a day, we are talking about the time the Earth takes to rotate all the way around once, so we're including the day and night, okay? But the amount of, what we normally obviously say, day, okay, it means 24 hours, but it also means the light part of the day where we have access to daylight. Now, the amount of daylight that we have during the day is something that changes throughout the year as well, okay? So sometimes we have longer days, sometimes we have shorter days. So for the next couple of, the next few minutes, the things I'm going to talk about, when I mention a day, I'm not going to be talking about the rotation of the Earth for 24 hours. I'm going to be talking about the time during the day where we can see daylight, okay? So when I say short day, long day, obviously we all know the 24 hours. I'm talking about when we can see daylight. So, have you noticed, you might know this, or have you noticed when, okay, when is the days shorter and when are the days longer? Okay, it's different times of year. So what time of year do we have long days, and what time of year do we have shorter days? If you don't know and you haven't thought about it, think about it. Think about your summer holidays. Think about the autumn when you come back to school. Think about Christmas time. Think about in the spring where you're leading up to summer. Which time of the year do you think you have the longest days, and which do you have the shortest days? And if you don't know this, you'll be able to work it out just from your life. Okay, so let's have a look. Longest days, shortest, this is your days. Okay, so let's have a look see. Okay, so some people saying, let's have a look, try not to miss anyone. Let's have a look what we've got. Team Mystic saying summer longer, winter shorter. Heidi saying summer long, winter short. Millie saying summer longer, shortest winter. Charge Gaming, leap year. We're talking about something else, and it's not 5 years, it's 4 years. Go back and look at our lesson a couple of weeks ago. Amelie, sorry, saying summer days and winter shorter days. Okay. Maya, winter is shorter, summer is longer. So a lot of people there are agreeing, and you're agreeing because you are right. Okay. Our longer days are in summer, and our shorter days are in winter. And what happens is the days when in summer get longer and longer and longer, and they get what we call the summer solstice. If you ever hear about that, okay, in the summer solstice, okay, the summer solstice. Going to make sure I spell this right because I've just thought about mentioning this off the top of my head. Solstice, would I have been right? Oh, would have been right. Would I? Yes. The summer solstice is the longest day of the year. Okay, and then you can guess what the winter solstice is then. The winter solstice is the shortest day of the year. Okay, and obviously we know they're all 24 hours. What is meaning is we have the least amount of daylight in those days. Okay, so that's why it gets dark on a night a lot quicker during the winter than it does in the summer. Okay, now I'll be very impressed. I'm going to give you a minute or so to have a think and write those things down and see if people putting some facts down about the earth and stuff like that. It's great knowing some random facts, but what science is all about, science is about finding things out. Science is about not knowing something and finding out. Scientists, okay, are very, very clever people, but they don't just know loads of facts. What scientists do is they find out facts, okay, what people have already found, and they use those to try and work out other things. They use those to try and work out different things to do with science that we haven't learned anymore. So scientists out there are not just going out there being, oh, I know all this about science. They are trying to find out things that we don't know. So let's see if we can do this. So it's all about asking questions. We know summer has the longest days. They get longer and longer and longer, then they start to get shorter into winter, get to the winter solstice, the shortest day of the year, then they start to get longer again back into summer. Okay? But let's ask ourselves a question. Why do we think that happens? Okay? Now I'm going to show you in a minute. I've got a diagram up here to show you. In the chat, can you please put, why do you think days are shorter and in the winter and longer in the summer? I've drew this diagram, okay? Now this diagram I've drawn on the board is going to help me to explain to you why that happens. Can you use what we've learned in previous lessons, what you know about Earth, what you know about the solar system and orbits, and the Earth and the rotation, and the sun and moon and all those things? Can you use the facts out of those to come up with what we call a hypothesis, okay, hypotheses, okay, of why do you think summer days are longer and winter days are shorter? Okay, I'm going to rub these off and have a look at the chat before we go over it. Okay, had time to note those down there now. So let's have a look at the chat and see what we are seeing. So down there, you're saying that we get more sunlight in the summer and less in the winter. You are right, but we are scientists, so we need to know more, okay? Why do we get more sunlight, okay? Why do we get more sunlight? So Isabel thinking that the sun's closer than, so we did say that the orbit isn't a complete circle. So it could be that, okay? The Earth rotates and the sun would be in different positions, Maya. Some good thinking there, okay? But there's something else in with that we need to mention. I'm going to see if anyone mentions it. Okay, now a lot of people there are starting to mention about the clocks going back and everything, okay? Now, this might blow your minds and things like that, okay? But technically, the way that we measure time was invented by humans, okay? Time used to happen, things would just happen over, obviously, things like that. Well done, Amelie, okay, the first person to mention it. Okay, well done, and then not well done as well. So clocks have nothing to do with the sun. Have a think about it. If I've got a clock up on the wall, okay, and I move the minute hand round, so the minute clock hand is wrong, does that mean that the sun moves in the sky in a position to make that clock right? Okay, there is not some big magical clock in the sky where when it moves, the sun moves, okay? Clocks and time have nothing to do with the sun, with daylight and stuff like that. It is just the way that we measure it, okay? The same way, let's say, if I was talking about my distance from here to the school, okay? If I was talking about my distance from here to the school, now I'll probably measure that in miles because of the distance that it is. So it might be, let's say 23 miles. I'm not sure, it might be around about that, probably less. Let's say 20 miles, okay? Let's just say that's 20 miles, all right? Now that distance between me here and that school, if I don't move, is not going to change, and it will always be 20 miles. However, if I change the markings on the ruler and said, all right, now it's 30 miles, that wouldn't make the distance any bigger, okay? The 20 miles is what we use to measure how far it is from here to there. A clock and time is the same way we measure how days pass and how days and years and things like that pass. So time and years and clocks and all that, okay, don't have anything to do with it. So some really good ideas. We have to put our clocks back because of the orbits and the things that we've been talking about. So the things that we've been learning back cause the clocks to go back. The clocks going back don't cause that to change, okay? Just wanted to go over that because a few people mentioned clocks there, okay? So we're going to have a look now. Now, there was one person, it was Amelie, mentioned the axis. Remember what the axis is. Look at this line going through my planet, okay? The axis is why when I'm spinning the planet, I don't spin it like that. I spin it like that. Because we are not straight up and down like that, we're on a little bit of a tilt, okay? Our oblate spheroid of a planet is on a little bit of a tilt, okay? So that means you can see I have drawn, okay, I have drawn a red line across these planets. Now, if you looked at a map and it was flat, okay, we would have the equator going across the middle. Remember, that's that imaginary line that breaks the top half of the planet and the bottom half of the planet up. So I have drawn that across, okay? So this is half of the planet. Now, because we are tilted, okay, imagine this is the Earth and it's going around the Sun. The Sun is a lot smaller and the Earth's a lot closer. I haven't got a whiteboard big enough to make a huge diagram for you where you'd be able to see on camera. So we've got to remember that we've got this planet here, okay, and it's going around the Sun like that. So when the Earth is on this side, okay, the countries in the northern hemisphere, okay, and that's what I'm going to talk about first because that's where most of us are from. I did see someone saying they were from Sydney yesterday. But most of us are from this northern hemisphere, okay? I'd say 99 to 100% of us are from the northern hemisphere. So when it is this time of year, we are tilted away from the sun, okay? So this is what we call our winter. We are tilted away from the sun. Now, if you have a look at my equator, okay, if I cover that bottom the bottom part, sorry, and you can just see the top, you can see that the sun is not tilted. The sunlight travels in straight lines. It doesn't bend round. So I have half of it dark here and half of it light here. So if our planet was straight, okay, and just spun around like that, our days would be 12 hours dark and 12 hours night, and it wouldn't change, and we wouldn't have the seasonal change, which we do. But because it's tilted, you can see there that not half of it is in darkness. You can see that more than half is in darkness, okay? This small section here is light, and this section here is dark. That means that this is the night, and this is the day. There is more night than there is daytime. That is the winter for the northern hemisphere. However, when the planet moves round, the tilt, I've lost the world, okay? The tilt doesn't turn and go from that to that. It stays tilted like that. So when it's on this side of the planet, and remember I've drawn the UK on this side and that side because it does spin as well as it's going, okay? So when it's on this side, if I cover my hand again, you can see that more of the Earth on the top northern hemisphere is light than dark, okay? That means there is more daylight hitting the Earth as it spins than there is darkness, and this is our nighttime. So when we look at it there, we can see that there's going to be less time when it's dark than it is when it's light, and that's why we have our summer and our days are longer, okay? So you can see the percentage change. And obviously, as we're going around this way to that, the days are getting longer. We have our summer solstice, then they get shorter, come round, and we have our shortest day, our winter solstice. Now, I've been saying about the northern hemisphere. When I talk about the northern hemisphere, I'll write that on the board in case you want to make a note. Okay, the northern hemisphere, and we also have the southern hemisphere. Now, when I've been talking about summer and winter, I have been talking about not the whole planet, not the whole of Earth, but the northern hemisphere, okay? So I've been saying that's when we have winter, that's when we have summer. However, if we have a look at the southern hemisphere, so I cover the top half, when we are getting shorter days, look, you can see that because of they're on the bottom half of the planet, they're actually tilted towards the sun. So have a look at how much is dark and how much is light there. Okay? There's the northern hemisphere, there's the southern hemisphere. In the chat, can you tell me what do you think that's going to cause? And there we go. There's our more in the light. Okay? There's less in the light. What do you think that causes in the southern hemisphere? Okay? So in the northern hemisphere, when less of us is in light, more of the southern hemisphere is in light. In the northern hemisphere, when there's more light, there's less in the southern hemisphere. What do you think that causes? Okay, what do you think that causes? Let's have a look. Yes, Emily. So northern hemisphere above the equator, southern hemisphere below the equator. Basically, that halfway line cuts the two out because it shows exactly when it's halfway, okay? Alright, I'm going to put some people in time because there's answers, but they're hidden between things. Okay, so you're seeing longer night, Emily? Hotter and colder you're talking about, Milo. You're onto something, but try and think about that more, okay? Try and think about explain. So, there's some ideas, some people, seasons, right? Well, brilliant, Emily. You're starting to think of seasons there now. So it is something to do with the seasons that I'm talking about, but what might be different? Okay, what do you think is different between the northern hemisphere's seasons and the southern hemisphere seasons. So you've used what you know. You said, all right, okay. One of you mentioned that their days are going to be longer here and shorter there, and the seasons are going to be different. So what do you think is different from the northern hemisphere seasons to our seasons? More heat, less heat as well, people are mentioning. Well, if you have a look, if you're here, you're going to be closer to the sun, aren't you? And here you're going to be further away. So yes, that means here you're going to be hotter and here you're going to be colder. So let's give you the last little clue. So from what you've all told me, I've not said this is from you in the chat. You've told me here we have long days and it's hotter for the southern hemisphere, and here we have shorter days and it's colder. Whereas in the northern hemisphere, we have short days and colder, long days and hotter. So has anyone mentioned it yet? Yes, Smith family, it does mean different seasons, okay? So well done, we've got there. So we've used our minds and put them together from what we know. It means the southern hemisphere seasons are the opposite to us, okay? So if you live in Australia, South America, you live in Africa, those sort of countries that are in the southern hemisphere, and obviously a lot more. If you live in those, when it is winter in the UK, it will be, or the northern hemisphere, UK, United States of America, China, all those countries, when it is winter, it will be summer for the southern hemisphere. When it is summer in the UK, it will be winter in these countries. Now, if you're close to the equator, okay, you're more likely to have hot times all around the seasons, okay. But if you are lower, okay, so say in Melbourne, Australia, or something, when it is Christmas Day, it will be it'll be around about the hottest time of the year. It'll be like summer, okay. And then when you get into June, July, August, those times of year, it will be the coldest time that you're going to experience in your country on that time of the year, okay? It's really weird, and I've experienced myself. Don't know if you mentioned, but I went traveling once, and I did live in Australia for a little bit, and when I was there, at Christmas, when it was really sunny, and the hottest time of the year, that is a really strange, when you've lived for too many years, okay, in the UK and it's cold. So they have the opposite seasons, again, because of that tilt. If we were straight and there was no tilt in the axis, okay, and we just turn around like that, they will be the same on the northern and the southern hemisphere, okay, all the way around. Now, also because of the tilt, okay, this is just a cool little fact. There are some times of the year, I'm going to write about the opposite seasons there. There are some times of the year, sorry, can't multitask, have opposite seasons. There are some times of the year when the North Pole and the South Pole, okay, have I think it's quite a long time, and it is constantly daylight, because you can see here this North Pole is tilted. So if the North Pole is here, it is constantly, okay, going to have day, and here is constantly going to have night. And the same here, you can see no matter where this there spins, the North Pole will always have night. South Pole, however, will always have day. So the North and South Poles are still very cold because of where they are on Earth, but sometimes of the year they have constant nighttime and sometimes they have constant daytime. Again, all caused by this tilt that we have on our planet. Now, what we are going to look at, I'm going to get rid of my tilty worlds, okay? We are going to look at how this affects shadows on our planet, okay? We're going to have a look at how it affects shadows, okay? So, I've got my sun here, and I'm just going to draw a couple more. Obviously, imagine that they're the same size. Just do them quickly, okay? And this is the path of the sun, okay, during the day, okay? Let's put some, we've got a lamppost here, and we just start to curve it because the earth is not flat, okay? And we have the earth thing here. Now, this that we're going to talk about now is how people used to be able to tell the time without complicated watches, clocks, things like that, back years and years and years ago. So we've got a little compass here to tell us this way is north, so we're going that way, remember, not up. North is not up, it's towards the up if you're going on a map, okay, but it's not straight up, okay, it's towards the North Pole. South will be down this way towards where you are. We've got east here and west there, so we know that because this is the east, our Earth, sun is going to, if we had a camera sitting there all day taking pictures, okay, it would move and it would look like it was going that way across our planet, okay. Now, what this causes is here, when the sun is there, we would have a shadow from here being very long. I'm not going to draw it as complicated there, okay, very long and going to the west, okay. Now, as the sun came further up, okay, we would have the shadow a bit shorter, still going to the west. Then the sun would get to noon, high noon, okay, be up in the sky, and it would be going straight down, shorter, but be going straight down towards the south, okay. Then it would start its descent to sunset. I'm just trying to get these lines straight. I'm doing these by freehand, so please let me off. Okay, oh, you can't let me off on that one. Again, a bit longer, and going to the east now, okay. And then we have our last one. You might want to draw this diagram, okay. It would be longer, but still going to the east, okay. Now, this is how people used to be able to tell the time, because they could, you might have heard of what a sundial is, okay. They could put something that would not move, and as the sun moved over the day, the shadow would move like a hand on a clock, okay. Obviously, you can only do 12 hours, because you're not going to get any shadows at night, but you could have a hand, like a hand would move around like a clock, telling you what time of day it was. Now, again, it could be, I think it's, I'm just going to say this roughly, Google it if you don't know the exact one. I think it could be up to 16 minutes too fast, and it could be up to about 40 minutes too early, depending on the time of day. Okay, so they could be slightly out. Now, back then there wasn't as much focus on exact times, sort of, let's say, the bus service and train service. You have to be that time when the trains left, because time wasn't as accurate back then. Okay. You didn't have to be as accurate, and as they got on, they would get further and further. Even the sundials would become to be able to tell you what time it is. So we have some data there. Now, what we haven't looked at in these science lessons is we haven't looked at what we can do with data, okay. So we have some information here now. We have some data. Now, a lot of time people think data is numbers and this, that and the other, but any information that you get, we class as data, okay. Or data, if you're data, sorry, how do you say it in America? Data. It's data, okay? So data. So this here is information that we have. So we can put this onto a table, or we can put it into a graph to help us work things out. Because yes, it shows us and it looks lovely there now, okay? But we can put this information onto something that's going to help us, okay? So I'm going to give you a minute. I'm just going to do 20 seconds or so. Oh, no, I'm going to rub it out now, actually. I'm going to rub this out again. If you want to copy it later or anything like that, you can watch the video again and pause it. And what we're going to do is we're going to use that data, and I'm going to draw a rough graph. This wouldn't be exact, okay, because I'm just doing it obviously on camera. So I'm going to draw a graph, and what we're going to do is we put data in graph to be able to spot patterns, okay. So we're going to see if we can spot a pattern. So here we have a graph, okay, and I'm going to draw a bar chart, okay. So what we're going to say here is, on a graph we should always mark our different axes off, okay, our x and y, okay, x on your decks, y in the sky. Remember that for maths, okay. So this along here is going to be the time, okay. So as the day goes on, I'm going to put my data on. Now this up here, okay, is going to be the height. So we're only looking at two variables, two things that change on there. So let's say 7 a.m, 9 a.m, 11 a.m, 12 a.m, 2 p.m, 4 p.m, and 6 p.m. Okay. So we have to have a unit of measurement along there. So I've got my hours, my time of the day, and I have to have one up there. So in height, I'm going to put an M, which means that's in meters. Okay, I'm not going to put the exact what each meter is, which you would do if you were doing an actual scientific diagram and having a look at it. But I'm going to draw a graph now, and I want you to tell me. So this is my title, length of shadow during the day. Okay, so that's how long it was at 7 a.m. Let's say that goes up to about 7 meters. So that'll be 3.5 meters, and that's 0 meters. Okay, so 7 a.m. we said that was around about 7 meters. Then it's coming down at 9 a.m. 11 a.m. we're going to see it's down around here. 12, and like I said, this is just rough. It's not something I've done. And obviously, to do this, you would have to have a stationary object, unless you have the patience to wait there all day. Now we have some data. Can you tell me what information, what facts can you tell me from that graph? Okay, so I'm going to colour in my bars. Okay, I'm gonna, from the pattern I can see, colour them in different colours. Should choose reds and oranges, shouldn't have, with it being the sun. But what can we notice from this? Okay, what facts can we see? As scientists, we've got some data. Okay, did a little experiment with our shadow on a lamppost. We've now put it into a graph so we can spot something, and we've had a look at the time of day and the height. So what facts can we come up with from that? Okay, well done, Milo. So at 12 o'clock, the shadow is going to be at the shortest. So at noon, your shadow and every other shadow is going to be the shortest that it is going to be all day. Okay, brilliant. And Amelie's extended that and put that into another way. She said at the point when the sun is directly above, it has a smaller shadow. So the point of the day where something is directly above us, it will have the shortest shadow. Well done. That's a really good way to put it there, Amelie. Okay, well done. Abdullah's saying at 6 p.m. it's the longest. Just 6 p.m. though, because if we have a look, okay, at 7 a.m. it's around about the same length, isn't it? So at 6 p.m. and 7 a.m. okay, that's when we have the longest sun. So when's that? Just as the sun comes up and just as the sun goes down, we have our longest shadows. Okay. So again, people have mentioned 6 p.m. It's about the same, isn't it? Okay, and obviously it depends what time of the day. But what we can see, because it changes every day, on this day it was, but we know that days change. Okay, the daylight when it comes, sometimes the sun will rise at a different point. So if I'm thinking about how can I say this is a scientific fact for all the days, I would say when the sun rises, just after it rises, and just as it sets, that is when things have their longest shadows. Okay, now we can see, another thing we could say is shadows start long in the morning, then they get shorter up until 12 o'clock, okay, and then they start to get longer again up until the day ends. Okay, so that's one piece of data we can have from that experiment. Okay, another piece of data we can get, so again, if you're copying that down to have a look and write some findings, is what we call them, from our graph, you can pop them underneath. Okay, so the last thing that we can think of, and I'm going to put like we might look like a strange bar chart to you. Okay, a stranger bar chart, but I'm going to put them on a bar chart where we're sideways across. Okay, so this time I'm going to put the shadows on. I'm going to put the lengths on. Okay, but what I'm also going to add on is the direction, okay, in which you're pointing. Now again, this is just rough, so these are about the same size, These are about the same size. So let's put our times on. Let's say this is 6 p.m. Remember, we always 6, 4, starting a.m. Mr. B, 2 a.m. And let's go up the same way time does. Mr. B, 9, 11. Let's say this is 12 p.m., 1 p.m., or 2 actually, 4 p.m., and 6 p.m. Okay, so now we have the time going down. Okay, and this is how long the shadow is, but also what direction. So over here I've got east, and over here I've got west. Okay, so I can see it's 6 a.m. my shadow is long and it's pointing towards the east. Okay, it's going out to the east on my graph. Okay, at 12 it's a little bit both because it's right down the middle, isn't it? And then at 2 p.m. is when it would start to go this way and point west. Okay, so again, now we have some data and we put it on a graph. What conclusions, what findings, what facts can you tell me from this graph? Okay, so this is telling us the length of our shadows during the day. Okay, let's have a look. Yeah, no, sorry, I'm going to swap these over. Mr. B made a boo-boo. So on here they are pointing to the east. Okay, I put my times on upside down. That's why I was getting mixed up. So if we're coming down, technically I should have my times going up, shouldn't I? And that's why I hadn't mapped them over there. But at 6 a.m. in the morning, okay, we're pointing west all the way till the east. Okay, what can you work out from that graph for me? Okay, what can you see? What can you tell me? If I said there is a graph and I explained it to you, what could you say? Oh, well, I know this now. Okay, so if I said, right, 6 a.m. it's the longest, pointing to the west. 9 a.m., 11 a.m., 12, it's down the middle, so it's a little bit of both. Okay, then at 2 p.m., 4 p.m., 6 p.m., it's now pointing to the east. Okay, what can you tell me? Well done, Emily, coming up with a good hypothesis. You said when the sun is coming from the west, the shadow will face west. Okay, remember our sun. That's probably put you off because I had these mixed up first on. So I'll take that my phone. The sun travels from the east to the west. Okay. So have a rethink of what that little bit of information you put down there, Emily. So the sun goes from the east to the west. So can you change one word in what that sentence that you put, and it would make it right? Okay. Length of the shadows are increasing, yeah? Okay. So what we can see, what we can come up with, what we can summarize is that we could say in the morning, shadows point to the west, and in the afternoon, shadows point to the east. Okay. What we could also say is when the sun is in the east, the shadows will point to the west, and when the shadows are in the west, when the sun is in the west, the shadows will point to the east. So we could come up with the fact that shadows will point in the opposite direction to the sun. Okay, so if the sun, and that is when you think about it, it's logical, isn't it? If I'm standing here and the light's there, the shadow is going to point that direction. Okay, so from that graph and from that information that we've had, That's how scientists, that's how we create facts, okay? And that's a big thing about science, because it's great learning all these things and that knowledge, and that's what we do. But the main thing scientists do, and the main thing about science, is asking questions and answering them, okay? That is the main thing, answering questions people don't know what the answer to. Now, this is someone knew the answer to, but we need this in order to, in the future, if you want to be a scientist, to ask those questions. So when you're learning facts, when you're learning things, you should ask yourself your questions. It could be, well, why doesn't this happen? Or, well, what would happen if this, if we changed this? Or what would happen if this happened instead? Okay, and you do an experiment. So a lamppost and us marking the shadows, that would have been our experiment. We get the data and we put it into a graph, not just to make it look pretty. So it's easy for us to look at it and try and work out things that it means. Okay, work out a theory. Okay, is what we call it. So that is the work for today. Okay, there are in the Padlet, there are some worksheets linked to this lesson, so have a go at those. Click on the link to your 5 year 6 links. If they don't work straight away, I will get down and change them. I know there has been a problem with them this week. Hopefully they will be working now. There is also a Kahoot, so there's a quiz there to see what you've learned, what you've understood, which is really good. And next time we have a science lesson, live science lesson, we'll have a look at who won that one. So that'll be brilliant as well. Again, if you need any help, pop it in the comments. Socials, Facebook, Instagram and Twitter, Mr. Biggins123. On the Padlet there's an email as well that you can get in contact with us. I'm going to stay around now for a little bit in the chat, and if anyone's got any questions or anything they want to ask, then I will be around for a couple of minutes to answer those and to fix the Padlet if it's not working. Hopefully it will. Okay, so Kahoot's there, have a go at it. I would do the worksheets first. And there's, I think Mrs. Carthy put up a great experiment to do with shadows and things today, okay? So maybe you could do your own experiment in the garden, okay? So you probably have to set it up ready for tomorrow, but create something with a shadow, use some chalk, draw around that shadow at different times of the day, and watch the shadow move like our lamppost one did, okay? And let me know what you found out. Give me any pictures or anything like that. But there is something about that in the worksheets, okay? That Mrs. Carthy kindly put together. Okay, thanks a lot. I'm going to pop in the chat there now and see if anyone needs any help with anything. Okay. You're welcome, Sophie. See you later, Mohammed. Yes, Mrs. Carthy, it is a great day for the investigation. If you're up our neck of the woods. You're welcome, Mrs. Rice. Thank you very much. See you later, Milo. Ryan, if you go to the Padlet in the description, have a look. There is some of the work that's based on an investigation. It'll tell you everything that you need there. But basically, you can use anything that will create a shadow. Mrs. Carthy there has done the work, so she said maybe have a go at the Kahoot first. So I'd have a go at the Kahoot first, and then have a go at your investigation stuff later, okay? There's not going to be any problems with the Padlet. I'll just check. Link, sorry. YouTube. Oh, open. Right, guys, if you're trying your Padlet links, I'm just changing them now. I don't know what has happened this week. Don't worry. Okay. Mrs. Carthy has popped them in the chat, I think. Okay, and the Kahoot link is working. So if you want to go to the paddle later, you can, okay? See you later, Layla. See you later, Heidi. See you later, Seb. See you later, Isabel. I think I've sorted out the Padlet, guys, for 2 seconds. Right, I've sorted out the links for the Padlet, so they are there working if you need them. Okay, guys, the views have dropped down there, so it looks like people have went out and the Padlet links are working. Again, comment or the socials, anything like that, if you need any help with the work or you have any other questions. Hope you've enjoyed the lesson today. Remember, there's no art lesson tomorrow at 2 p.m, but there is a music lesson, okay? Again, all you need to do is come along. Music lesson tomorrow morning, okay? So come in tomorrow morning, 10 o'clock, and we will do it to it, okay? Catch you later.